Hello Math fans, Dr. Andy Lovell is going to talk about Chapter 4 of Math 120. In that section we introduced the equation of the line. As always in our pre-calculus course, we do it in an applied setting. So one of the homework questions that a lot of students are asking me about that I didn't cover in class is a question that says, what is the area bounded by these lines? That's interesting because I partially the reason I didn't do it in class is because I thought, well, they have to draw it. But I think it's worth me, after talking to students in office hours, saying a few things. These aren't exactly the same as the homework questions, but these questions that say find the area of the triangle formed by these three lines, or these three lines, or these three lines, the challenge, your job is to draw the triangle. We'll worry about the area after we've drawn it. All right, so let's review a few things about drawing a line. At any point, if you want to draw a line, this kind of goes for anything you draw in any course, plot points. And when it comes to a line, the easiest points to plot would be the intercepts. For example, when x is 0, what do you get for y? And I usually don't write that. I usually just write it like this and like this. And when y is 0, what's x? And then I just solve. That's the whole point of the equation. It gives us the condition. So if this is 0, then y is 4. It's written in the form y equals, and so that's why it's easier to find that one. But if the other one is 0, it's actually not that hard either. You can just about do it in your head. You got to practice trying to do some of these small things in your head. As I said, at this point, when you're getting into college math, you don't want to have to write -4 on both sides. You just want to be able to do it. And that's a practice thing. So I'm getting 4/10, which is 2/5. Okay, so at the end of this, through fairly little effort, that's what I would just do automatically. There are other ways to graph it. The fact that the slope is -10 means it's going down. You should know what these. So this will get better. But this is what you're practicing. This is the skill. So what I mean is, this is where you should spend your time here. If you're really having trouble graphing these, that's the bigger issue. All right, and then I'll deal with some of the other parts. So I know it hits here at 4, and really we should see that right away. That should be in our mind. It has a negative slope. Honestly, if I was just trying to do a quick graph, what I would have done is put a thing here at 4 and drawn a negative slope. I know that -10 is pretty steep, and so I would have drawn something like this. I'm not worried about being super accurate. It probably should be steeper than that, but my scales don't match. Then you got to realize, oh, there's my triangle. Now, why did I stop there? Because I mentioned the x and y axis. Okay, so at that point, then I'm able, so this sort of goes, there is a common theme in all our questions, which is if we're stuck, we should visualize, we should find the equations, we should translate. There's a bunch of steps I've been giving you to do, and then you sort of reevaluate and see what we want to do. We want that area. That area is 1/2 base times height. Now, most students have said they remember that formula. So yeah, I didn't remind you. You might, if you didn't know, you'd have to look up. It's half the area of the corresponding rectangle. I need those links. And then this is the other part of this problem. That's part of what we're learning, is be able to read those things off. If I'm telling you this point is 0, 4, that's telling you h is 4. If I'm telling you that this point is 2/5 0, then that's telling you the base is 2/5. So we're done. We have that area. Let me zoom in a little bit because I think I wrote off the page. Anyways, so I'm getting that this is 1/2. The base is 2/5 times 4. And so I'm getting that the 2's cancel. I'm getting 4/5 or 0.8. So for this one, I've got it. The area is 4/5 or 0.8 square units, whatever that would be. All right, that's the game. Now, the first homework question wasn't quite as short as that. The first homework question was something like this. They're still telling you it's a triangle, so we're going to play the same game. Now, in this case, I should say, one comment I should make about this last one is we actually found the intersection of these two equations. That's what happened when we plugged in y equals 0, and we found the intersection of those two equations. The origin I didn't actually find because I just already knew it was there. So when I look at this, there's actually, if this is helpful to you, there's 3 equations. One equation is x equals 0. Another equation, let's just pick one at random here, is y equals negative 1/2 x. There's going to be 3 intersections. One of the intersections is the intersection of those 2. So even before I graph, I feel like, oh, I'm going to have to at intersection. Well, when I plug in x equals 0, I get 5. So that tells me that 0, 5 is one of the corners of my triangle. It's the corner where these 2 things meet. Are there any other things that meet? Let's do an easy one. When does 1, this equation, and I'm just randomly numbering them, and 3, which is this equation, when do those meet? Go ahead and substitute that in. When x is 0, think of these as conditions. I've really been trying to emphasize how you think about equations for a curve. They're conditions for what it means for a point to be on that curve. So if you want a point to be on x equals 0 and on here, we combine. And that gives you 6 times 0, which is 0. So 0, 0 is another point. So I have 2 points of my triangle, 2 corners. There's one more to find. And that's the part that I think maybe the students are getting confused about, is I need to intersect those 2 curves. Honestly, I would have seen these other 2 points right away, and I just would have done that. So I need to combine these 2. When are those y's the same? Well, that would require that 6x equals negative 1/2 x plus 5. And I've had quite a few discussions in office hours with students about this. Some people like to add the 1/2 and write 6.5. There's absolutely no problem with that. What I do is I multiply both sides by 2. If I multiply both sides by 2, it immediately gets rid of your fractions. And I'm just kind of, there's nothing that says you need to get to the answer in the same steps I do. But clearing denominators basically means you almost never have to work with fractions, especially when you're solving. You still should know how to work with fractions, but I would always multiply times 2. That's sort of weird for students, but I'm trying to show students different little bits of algebra. But at that point, the solving comes really quick. You get 13x is 10. You get x is 10/13. At that moment, I feel like I'm ready to graph it. So let's do it. 0, 5. I think I'm going to erase this. You know that part. 0, 5, 0, 0, and this point we just found. So let's do it. And of course, my students, if I post something like this on the discussion board, please let me know questions in the chat. Sorry if I'm too long-winded and boring and overweight. All those things are true. I'm working on it. Trying to recover from a Mariner loss today. Okay, so we have these lines. There's one other point over here. It's 10/13. That's the x value. I didn't even figure out the y value. But I now know it looks like this. Now, in my head, I already had a picture of this. I knew this is what it was going to look like because I had a line with a positive slope that went through the origin. That's this one. And this is extremely valuable, the ability to look and work through a graph. It's more than just this question. This is not going to go away. So if you're not to the point yet where you can say, hey, this is a line that's going down, this is a line with positive slope, if you can't start to connect those in your head, then it's worth this time of pausing here. Okay, now when I look at that picture, I can see a base. And some people might say, why is that the base? Why is not something else the base? You can pick any of them to be the base, but you'd like to pick one where you can also see the height, and I can also see the height. It's the distance from here to here. So I have everything I need. You might say, how do I know that? Well, that's what x is. It's how far you go over. So we're done. Area is 1/2 the base, which I'm calling 5, and the length or the height, it's just 10/3. So it's 10/13. Sorry, I'm going to try to get wrong here. And people will be telling me I'm wrong for years. Okay, so 50/26. All right, so that answers actually your first homework question. I don't know why I wrote it that way, because I could have written 25/13. But I don't edit these things out. They're not, my goal when I'm making these videos is not to be perfect. I often say I'm trying to prove how dumb I am, to prove that you don't have to be smart to these problems. You just need an approach, and you need to sort of not let yourself be overwhelmed. But the goal here is not to be an expert in the area of triangles that have to do with lines. The goal is to be really good with lines. Okay, I just threw in one where there's an unknown. I say, what if I have a b value that's greater than 0? Then basically we're looking kind of like this first example. So there's a couple of problems like this that say, can you do it with an unknown in there? Well, what would change? It's still going to look like this. This point is going to be 0, comma b. That's the tricky, scary part. This point, I don't know what that is. I shouldn't use b because I'm using b for the base. Again, I'm not that smart. Okay, so this is b, and I want to know, you don't have to be smart to do math. I've been trying to prove that successfully for a long time. Okay, so I want to know when this is 0, what do you get? So you get 0 is equal to, and I'm trying to find what x is. Let me make sure I haven't gone off the screen. Sometimes I can't see. Okay, so I'm going to solve for x. I'm going to get negative b is negative 2x. I'm going to get x is b over 2. That's this point. This is b over 2. And the area is 1/2 the base, which is b over 2, times the height, which is b. And so now I can write the formula, 1/4 b squared. That's kind of cool. We found a general formula no matter what this is. You could go back and test it and say like, well, what if this is a 6? It almost looks like a 6. Then that means this would be a 3. And our formula would be 36 over 4, which would be 9. Does that match up with what I think this area would be? Yeah, it does. I hope that kind of helps. I'll probably follow up with a more like generic version of this, but let me know if things like this are helpful to you. It's very helpful for you to tell me in the comments or to let me know where you're getting mixed up.